Welcome back. This is an Aleks training video on predicting the relative boiling points of pure substances. So liquids, if you give it enough energy, will turn from a liquid into a gas. But not all liquids will boil at the same temperature or with the same amount of energy. It takes more energy to separate some liquids than others. The more sticky the liquids are, meaning that they are attracted together, the harder it is to get them to go into a gas, and it takes more energy and a higher temperature to do it. So we're looking here at boiling points and looking at the different molecules and trying to see what is it about these that would be stickier than others, and so consequently have a higher boiling point. So I've given you some strategies here on the side. First strategy, look for metals. Just metals, only metals. Because metal to metal, there's actually three types of bonds. We've looked at ionic bonds, where you steal electrons and become charged like an ion. We've looked at covalent bonds, where they share electrons in order to make a bond. The other type of bond is called a metallic bond, and it's just metals attached to metals. And it's very, very strong. It's the strongest of all of the bonds. So if you find a metal that's just by itself, that's got the highest boiling point. Absolutely will. Okay. So the second thing that I have here is the higher the molecular mass, the higher the boiling point. Okay. So if you've got lots and lots of atoms in it, you're going to have to get each of those atoms to have the energy to go from a liquid to a gas. So the bigger the molecule is, the heavier it is, the harder it is to make it into a gas. Okay, I guess you could make a bowling ball into a gas if you gave it enough energy, but it's hard. It's harder to have a 3-carbon chain go into a gas than it is for a 1-carbon chain. Okay, so you check out the molecular masses, and then the last thing that I wrote was if you aren't sure, and there's two things that have basically the same amount of mass. If you look at the periodic table and you add up the molecular mass in grams per mole, and they're roughly the same, check out for the intermolecular forces we've studied in this chapter. So are they polar? If they're polar, then they're stickier. Okay, that positive side is going to want to attract to the negative side of its neighbor, and vice versa. Look for hydrogen bonding. Hydrogen bonding is very sticky, and so it will have a higher boiling point than if it's just London forces. All right, so let's look at these 4 examples and see what we can do with them. First one, cobalt is a metal. All right, so you already know that that is going to be the highest. So I'm going to put that as number 1, and I think number 1 should be the highest. Okay, because it says choose 1 to the highest. Okay. All right. I see D as H2. Okay, H2 has a molecular mass of 2 grams per mole. Okay, it does not have hydrogen bonding because there's no electronegative atom there. It doesn't have it's not polar because they're pulling on the 2 hydrogens are pulling equally on the electrons. So my guess is it would be the lowest. It's nothing. Okay, so this would be 4, which is the lowest. Now, what about the middle? If you look at the molecular masses, okay, I looked them up. The molecular mass of the CH2 is going to be 28 grams per mole. Okay, so let's see, 28. Okay, and the H2CO is going to be 30 grams per mole. Okay, so that's really close. It's not close enough to, it's too close to say that the 30 grams per mole is higher than the 28 grams per mole. That's not close enough. So you're going to have to check and see, are there any other intermolecular forces? Okay, what other forces are there going to be? Okay, H2CO is polar because that oxygen is higher electronegativity than the carbon, and so it's going to be very negative on that side, and the carbon and the hydrogen side is going to be very positive. So it's going to be heavier. All right, so it'll be stickier, so it would have a higher boiling point than the other. The CH2 is not polar. CH2 does not have hydrogen bonding. The other one doesn't necessarily have much hydrogen bonding either because there's no H attached to the oxygen, but like other things would attach to it. So I would imagine C is going to be much higher boiling point than B. So that would make this would be 3 and this would be 2. Okay, hope that helps you.